Alright. Alright, listen up. So, like I said before, days 1 and 2 we spent on graphing, substitution, equivalent forms. Today, we're talking about the elimination method. I like to call it combination elimination. Some people call it just elimination. It's really up to you. So, as it indicates, what we're going to do is we're going to end up actually combining our two equations. We're going to give them to you. We're going to add them together so we can eliminate one of our variables. Now, when we eliminate a variable, we're left with only one variable, which means we'll be able to solve them. So the big idea here is being able to eliminate one of our variables so we can solve for the other one. This method is most convenient when each equation is in standard form, or when x and y are on the exact same side of the equal sign, just like in number 8 on the homework, where they're both on the same side of the equal sign. That is when this is most convenient, is to use elimination. Alright? So our steps here. Now we'll run through the steps, then we'll go through them again as we go along a problem. Do not freak out if you don't understand what it means right away. As we go through the problems, it should make more sense. Okay? Step 1 is to make sure they're both in standard form. Right? So make sure x and y are on the same side of the equal sign. Normally, if you're going to use this method, it's already done for you. Number 2, multiply one or both the equations by a constant in order to obtain opposite coefficients. What does that mean? Opposite coefficients. Well, first of all, hey, what is a coefficient? Does anyone remember? Any know? Big math vocab term, coefficient. If I give you like 3x, we call x a what? X is a variable. What's the word for 3? What is 3 called? A coefficient. So, the numbers in front of our variables are what we call coefficients. So like 3 is my coefficient for x. What I need to do is I need to get an opposite coefficient. What would be opposite of 3? Negative 3. So we are looking to get opposite coefficients in front of one of our variables, whether it's x, whether it's y, whether it's whatever variable we're looking at. So we want opposite coefficients. Because what we're going to do then is we're going to add the equations together. And what happens if I do 3x minus 3x? It's 0. It cancels. It goes away, and I'd be able to solve for y then. So we're trying to get opposite coefficients using multiplication. You can only use multiplication when we're doing this. Okay? So opposite coefficients through multiplication, so we can add the equations together and eliminate one of our variables. When that happens, step 4 is going to be to solve for that remaining variable. And just like we have been doing, once you have what one variable equals, you plug it back in, and we're going to get our second variable. Cool? So it seems like a lot right now. It's really not that bad, I promise. Okay? Should we try one? Yeah. Okay. First one. 3x plus 2y equals 10. 8x minus 2y equals 12. First of all, are they in standard form? Are x and y on the same side of the equal sign? Yes. Yes, in both of them. Good. That's a good start. Step 2. We need to multiply by some sort of constant to make opposite coefficients. Well, let's look at them. Look at the x values. Look at the y values. Do I already have opposite coefficients or opposite numbers in front of one of my variables? Yeah. I do, right? I have positive 2y and negative 2y. So I do not need to multiply by anything. Right? I can just go ahead and start combining them. When I do that, I am adding the two equations together. Add the x values, add the y values, add the constants at the end. 3x plus 8x is 11x. 2y plus negative 2y cancels, or it turns to 0. Remember that, it turns to 0. It doesn't just disappear. Right? Equals 10 plus 12 is 22. Hey, do you guys know how to solve something like that? Yes. Yeah, we can divide by 11. X equals 2. That's a good first start. How do I find y now?
Put that in for x.
Put it in for x in either of the two equations. Doesn't matter which one. I'm going to use the top one. So 3 times 2 plus 2y equals 10. Or 6 plus 2y equals 10. And then from here it's just solving it. Right? It's subtracting the 6. It's dividing by 2.
2.
Because you get 2y equals 4, and then like I said, divide by 2. Y equals 2. Is that good? Is that how I should leave my answer?
Parentheses, parentheses.
Write as an ordered pair. 2, 2. Alright? And is there a way I can check that?
Whoa.
Yeah, plug them back in, right? Guys, you should be able to check every single systems problem on the test. You should not get a single one wrong, so you can check them all. You can plug them all back in, and they should all become true statements. Alright, yes sir?
I have a question for the next problem.
Okay.
So is the x since like the last problem you did y since they equal you just cross them out and they equal 0?
Hold on, we'll get there in 1 second. Okay? I think you're on the right track, but you're not quite there. Okay? Alright, so guys, like I said, check your answers if you have time on the test. Okay? Second problem. X minus 2y equals 14, x plus 3y equals 9. Hey, what coefficient is technically in front of that x?
1.
1. So it's 1x and 1x. Okay. Step 1. Make sure they're both in standard form. Are x and y the same side of the equal sign?
Yes.
Yes. Step 2. Get opposite coefficients. If I look at my x values and my y values, do I have opposite numbers in front of either of them? No. Shh. Very careful. I have 1 in front of x and x, but are those opposites?
No.
No, I need 1 and -1. Now, I'm going to tell you this right now. It does not matter which variable you get rid of first. You can get rid of x if you want, you can get rid of y if you want. Now, some problems it'll be easier to get rid of a certain one, but it doesn't matter which one you get rid of. Okay? I'm going to try and get rid of x in this problem. I have 1x and 1x. So I need to make one of them be -1x. How can I turn one of them into -1x? Multiply by -1. I'm going to multiply the top one. It doesn't matter which one I multiply, because I'm both turn into -1. Now be very careful here. When you start multiplying by constants, we are not just multiplying x by -1. Everything in that equation needs to be multiplied by -1. So it becomes -1x. -2y times -1 is positive 2y. 14 times -1. -14. Okay? So I multiplied everything by -1. So my top equation turned into here. Do I have opposite coefficients now? Yes, so now I can combine them and eliminate my x's. 1x plus -1x cancels.
5y.
5y equals -5.
Equals
So divide by 5, we get x equals, or excuse me, y equals -1. Alright, that's part 1 done. We figured out what y is.
Plug it into x and plug it into
Which one? Which one do you want to plug it into?
the bottom one.
This one?
Yeah.
Okay, plug y into one of your two equations. We're going to use the bottom one. 1x plus 3 times -1 equals 9. What's 3 times -1? -3. So then just add 3 to both sides. X equals 12, which means 12 comma -1. Hey guys, right, if you have trouble remembering which one comes first in the order pair, think about the alphabet, right? X comes before Y. Okay? 12 comma -1. Alright. Any questions at all? If you flip your page, I believe there are 2 you try problems. I want you to try only the first one. Try C, we will do D together because it's a little bit different. So try C and then we'll do D together. If you have a question, please make sure you ask. Like I said, it doesn't matter which variable you get rid of, but one of them is probably easier than the other. Well, we multiply this so we get opposite coefficients, right? Then we combine the two. This is our new one from up here. X's cancel out and also just y's. So it's just 1. Right? If you want to make it so the y's cancel out, it's a little more work, but you could, and then you can solve for x too, and then plug it in. It doesn't matter which one you solve for first. Just whichever one gets eliminated, obviously you solve for the other. So then we take y, and we plug it in to our equation. Yep. So we have x plus 3 times negative 1 equals 9. Just like we have in those other problems, we take whatever we find first, and we plug it into one of our two equations to find our other one. Okay?
No, I literally do sit next to each other.
Alright guys, hey, should we go through it? Yo! Hey, should we go through it? Yeah. Alright, so let's look at them. 2x plus 5y equals 1. X plus 2y equals 0. Think about it for a second. Are they both in standard form? X and y on the same side?
Yeah.
Yes. Do I have opposite coefficients already?
No.
No, I need to make them. The easiest way to go about it, I think, would be to deal with x, with 2 and 1. Now, what could I multiply one of the equations by to get opposite coefficients?
Negative 2 on the bottom.
The negative 2 on the bottom. Guys, we are not always multiplying by the same numbers. It's whatever number you need it to be to get your opposite coefficients. So we're going to multiply this bottom one by negative 2 so that I can get 2x and negative 2x. Right? So negative 2x minus 4y equals 0. And I'm just going to bring that top one down with me. 2x plus 5y equals 1. Now I have opposite coefficients. Now I can just combine them. 2x plus negative 2x cancels. 5y plus negative 4y gives me 1y equals 1. Well, it's easy. I don't have to do any solving now for y. Okay, so you get y equals 1. Then you plug it back into your equation. I'm going to plug it into the bottom one. X plus 2 times 1 equals 0. Well, 2 times 1 is 2. And then to solve for x, I would just subtract 2. X equals negative 2. Okay? But your answer's in ordered pair, you get negative 2, comma 1. Alright? Are there any questions on that? Any at all? I know I kind of flew through it, but do we have any questions? Alright. If not, I want to do the next one together because it's a little bit trickier. If you look at it, 5x plus 4y equals 7, 2x minus 3y equals 12. Are they in standard form? Both x and y on the same side of the equal sign?
Yeah.
Yes. Do I already have opposite coefficients for one of my variables?
No.
No. I need to figure out what I can multiply by to get rid of one of my variables. Once again, it doesn't matter which variable you get rid of first. You can get rid of x or you can get rid of y. You should still get the same answer. Bailey, do you want to get rid of x or y? X. Alright, so let's look at x. I have 5x and I have 2x. Well, usually we're going to work with a smaller number, but is there anything I can multiply 2x by to get to the opposite of this, which would be negative 5?
No.
No, not without using like decimals or something, right? We don't want to deal with decimals. We don't want to introduce decimals to this. That would make just a big mess. So what's going to happen is I'm going to multiply not just one equation,
The other one.
but I'm going to multiply by both equations by some numbers. It does not have to be the same number for both equations. You can use different numbers. So what I'm going to do is I'm going to notice, well, 5 and 2, they can both multiply to 10 and negative 10, right? So I'm going to get the top one
Oh, by 2 and the bottom one
by 2 to get to positive 10,
5.
and the bottom one by negative 5 to get to negative 10. Right? We're using whatever numbers we need to get to where we need to be. So if I multiply all the way out here, I get 10x plus 8y equals 14. I get negative 10x plus 15y equals negative 60. Because remember, those constants get multiplied by every single piece of my equation. And now I have opposite coefficients. Now I can go ahead and add them together. 10x and negative 10x cancel. 8y plus 15y is 23y equal to negative 46. Alyssa, what do you think I should do here to solve for y?
Divide by negative 23. Or by 23.
By 23, right? Divide by 23, good. I get y equals negative 2. Perfect. Now take negative 2, plug it in for one of our two equations for y. I'm just use the bottom one because that's one I can see right now. 2x minus 3 times negative 2 equal to 12. What's negative 3 times negative 2? 6. So 2x plus 6 equals 12. Solve for x. Minus 6 and divide by 2. X equals 3. Okay? So once you find that first variable, plug it back in, find your second variable. 3, negative 2. Alright. Any questions on those? So sometimes you need to multiply both your equations by something. Sometimes you need to multiply one of them. Sometimes you have to multiply anything. Sometimes they'll already be there for you. Alright? Cool? Alright, let's talk a little bit quickly about our special cases. There are two types of special cases. One where you get no solution. One where you get infinite many solutions. If you look at a graph here, and you see parallel lines, why would that be no solution?
Because they're never going to connect.
They're never going to intersect, right? We said on day 1, where they intersect is our solution. Well, if they don't intersect, there can't be a solution. So if you ever graph two lines, and they are parallel, they don't intersect, your answer is going to be no solution. Also, if you're solving, like the method we just used, and your variables cancel out, both of them, not just one of them, but both of them cancel out, and you get a false statement, that means there's no solution. There's no numbers you could possibly put in there that would make it work. Now, infinite many solutions, if you look at that graph, it looks like there's only one line there, right?
They're on each other.
That's because they're on each other, they're both the same line. If that happens, we have infinite many solutions because every single point on that line is going to be a solution. So there's infinite many. Now, does all real solutions work? No, because that would say, then this over here is a solution. Is that true? No. So all real solutions is not an answer. Infinite many solutions mean there's a ton of them right in that line. Okay, so be very careful about your wordage there. Could make a difference. It would get marked wrong if you put all real solutions. Same thing if you are solving, everything's eliminated, but it's a true statement. Infinite many solutions. So there's a ton of them that you can put in there. Alright? So let's fill in this little table quick. We'll do 2 problems, we'll be done. If the equations have different slopes, which means they're 2 separate lines, they're going to intersect at a point, how many solutions should you get?
2. 1.
1, right? You're going to have 2 numbers, but it's going to be 1 solution. Okay? If they have the same slopes with different y-intercepts, which means they cross the y-axis at different points, but they're the same, so they're parallel to each other, How many solutions do you have if they're parallel? What do we just say? There's no solution, or there's none. Right? And then, same slopes, same y-intercepts. In other words, they are the exact same line.
Many infinite.
You're going to have infinite many solutions. Or just, if you want to put many, I would accept that as well. Infinite many solutions. Alright, so let's look kind of here, solving two of our special cases. We're using combination elimination here. 3x plus 2y equals 10. 9x plus 6y equals 6. I'm going to get rid of x in this case. So I'm going to multiply this top one by negative 3 to get to negative 9. Negative 9x minus 6y equals negative 18. Actually, negative 30. I don't know what I was looking at. Negative 30. Alright? Add them together. What's 9x plus negative 9x?
0.
0. What's 6y plus negative 6y?
0. No solution.
6 plus negative 30. Negative 24.
No solution.
0 does not equal negative 24. That is a false statement, which means our answer is going to be no solution. Next one's fairly similar. I have 5x plus y equals negative 2. Negative 10x minus 2y equals 4. If I try to get rid of x again, I'm going to multiply the top one by 2. 10x plus 2y equals negative 4. I go to combine them. Negative 10x plus 10x is 0. Negative 2y plus 2y is 0. 4 plus negative 4 is 0.
That's true, but that's true.
That's true. 0 equals 0.
So that's 1, right?
So that's going to be,
Different slopes or something.
either you could write many solutions or the infinite many solutions. Either way you want to write it. Right? Because that's where they'd be the same line then. They'd have all these different points that work, but not every point that works. So infinite many solutions. So those are the two special cases you're going to see. Alright? Any questions? Alright, sweet. We're done.
Subscribe.
Subscribe. Swipe up.